is functions. Okay? Chapter 4, Lesson 1 is representing relations. So, for the what you'll learn, predict two things you'll learn about in linear equations. We're going to learn that linear equations can contain more than one variable. Okay? If you didn't write that, add it to your notes. Okay? Linear equations can contain more than one variable. And a linear equation is an equation with a graph that is a straight line. It's a little spaceship problem. To achieve orbit, the space shuttle must travel at a rate of about 5 miles per second. The table shows the total distance, d, that the craft covers in certain periods of time, t. Now, if you'll notice here, I switched number 1 and 2 because I think that it's easier to describe in words, and then from the words that you figure out, write your equation. Okay? So, describe the relationship in words. In other words, how did you get from t to d? First column is time in seconds. Okay? Distance in miles is the second column. How did you get from the first column to the second column? Take a look.
3 times 5, 10.
You're going to multiply times 5. How do you get from t to d? 1 times 5, 5. 2 times 5, 10. 3 times 5, 15. You see that? So, to get from t to d, it's the distance, the d is the distance, is 5 times the number of seconds. Okay? So in words, that's what you're doing. You're multiplying the number of seconds times 5. So now that you have those words, what is the equation you're going to write? Here, write an algebraic expression for the distance in miles for any number of seconds t. Here, write an equation for what you came up with up here. What equation did you come up with?
D equals 5t.
D is equal to 5t. Very good. So here, this 5 times t, that is equal to the distance. So d is equal to 5t. All right, so tables, graphs, and equations. Recall that an equation is a mathematical sentence stating that two quantities are equal. A linear equation, if you didn't write this down already, you should write it down now. A linear equation is an equation with a graph that is a straight line. Okay, and of course, also, sometimes these equations can have more than one variable. So our first example says the total cost of tickets to the school play is shown in the table. Okay? We want to A, write an equation to find the total cost of any number of tickets and describe the relationship in words. And again, I told you I like to do the describing in words first before writing the equation. Okay? Then it says use the equation to find the cost of 15 tickets. Okay? So the first thing I want to do is this part right here. Describe the relationship in words. How am I going to get from the number of tickets to the total cost? How do I get from the first column to the second column? So, yes, when you are, to get from the first column to the second column, you will multiply the cost of a ticket times the number of tickets you purchased, right? So, if we're going to write that in words, let's write it down here. So this is going to be A. So, the total cost is the price of a ticket the number of tickets purchased. Okay? So, if that's the description of the relationship in words, how would I write that relationship using algebra? How would I write that relationship in an equation? All right. So to write this in equation, the total cost, which is C, is equal,
Is that B?
No, we're still writing the equation.
Oh.
Okay? So the total cost, C, is the price of a ticket, which is how much? $4.50. $4.50 times the number of tickets purchased, which would be any of these numbers, which would be
Times T.
times T. And there's your equation.
That's not.
So now part B says, use the equation to find the cost of 15 tickets. How do I do that? You're going to substitute 15 in for T. Very good. So at this point, you're going to, now, for B, you will evaluate. How do you change colors? Evaluate your equation for T is equal to 15. And you remember what evaluate means, right? Evaluate means to what? Substitute and simplify. Right? So substitute is plugging it in. Substitute is plugging it in. So substitute and simplify. So for part B, we're going to substitute 15 in for T. So C is equal to $4.50 times 15. So what is your total cost?
That's that.
All right. So that would be 67.5. Is that your answer?
Booyah. No.
This is money. So how much money is this?
68.
$67.50.
50 cents.
50 cents. You just add your zero, right? And of course, you're going to label it with dollars.
Dollars.
That's it? The next example says, write an equation to find the total number of trees, Y, that can be saved for any number of tons of paper, X. Okay? So, and then part D says, use the equation to find how many trees could be saved if 500 tons of paper are recycled. So if you look here on the graph, it says the number of trees recycled, or the number of trees saved by recycling paper is shown here in the graph. So if we recycled 1 ton of paper, 17 trees are saved. If we recycled 2 tons,
34.
if we recycled 3 tons, you see?
51.
You see? So even though this is in graph form, don't you still have 2 columns?
So you just pretty much ignore the first number.
I'm going to show you. This is the tons of paper, and this is the number of, they use X and Y. Let me use X and Y. Okay. So this is your X right here, and this is the Y. And the X represents the tons of paper, and the Y represents the total number of trees saved. Okay? So when you look at this, okay, the first one, X comma Y, is 1 comma 17. Does that look familiar?
Yeah.
Looks just like the last problem. Here, 2 comma 34. You see how you can see a graph in table form?
Mm-hmm.
Let's just do the rest of them. So 3, 51. 4, 68. And 5, 85, comma, 85. So, here is what it looks like in the last problem. This is my your data in a table form, where X represents the tons of paper, and Y represents the number of trees that were saved. You see, it's all the same, right? So, it says write an equation to find the total number of trees that that can be saved for any number of tons of paper, X. And again, I like to put it in words first. So, how do I get from X to Y? How do I get from X to Y? All right, so to get from X to Y, all you're doing is multiplying times 17. So 1 times 17, 17. 2 times 17, 34. 3 times 17, 51, and so forth. So we multiplied the number of tons of paper recycled. We're going to multiply that number times 17, and that will give us the total number of trees saved. Okay? So that's how we write it in words. All right. So the total number of trees saved is the tons of paper recycled times 17. So how do I write that as an equation? How do I write it as an equation? The total number of trees saved. That's what we're trying to find, right? So let's call that, oh, that's Y, right? That's my Y value. Is, how do you write is in math? Equals the tons of paper recycled, X, times 17. And remember, in math, we always put the number before the variable, right? So there is our equation. Y is equal to 17x. You got it? Part D says, use the equation to find how many trees you could be saved if 500 tons of paper are recycled. What do I do now? We substitute in. You're going to substitute 500 tons of paper, 500 tons of paper in for X. Yeah. So we've got Y is equal to 17 times 500. What do you get? 8,500. 8,500 what? Trees. We're saved. So, multiple representations of linear equations. You've already seen all 4 of these. You've seen it in words. You've seen it in words. How we described it. Okay? Then we took that description and we changed it to an equation. So you have words and an equation. And you saw a table. Or your data organized in a table. And of course, you all what you complained about, you saw the graph. Okay? But remember, if you have the graph, you can change it so you can understand it. You can change it to a table. So, last example. Paul earns $25 for grooming a dog plus $18.50 per day for boarding that same dog. Write an equation to find the amount of money Paul earned, M, for grooming a dog once and boarding it for any number of days.
So boring me.
Boarding means that you're letting the dog stay in the kennel. Okay? And then part F says make a table to find his earnings for 5, 6, 7, or 8 days. And then we want to graph the ordered pairs. So the first thing we want to do is write an equation. We already have the words right here, right? What words here tell me an operation? What words tell me the operation? Plus tells me that I need to add. What else? Per means what? Very good. Per means multiply. So, when I'm looking at this problem, it says Paul earns $25. We're going to add $25 for that grooming, right? $25 for the grooming. We're going to add that to the $18.50 per day. Okay? So how do I write that equation? How do I write that equation? And it says the total amount M. So M is the total amount, right? What's my equation?
25 plus
25
18.50
plus, 25 plus what?
times
$18.50.
D.
Very good. Times D. Times however many days the dog stayed at the kennel. Right? So, there's your equation. So, now we want to make a table to find his earnings for 5, 6, 7, or 8 days. Okay, now when you have your table, you're going to have your titles up here in the first row. Okay, where D, the input, is the first one. That's your input. Your expression part of your equation goes right here. So this is going to be 25 plus 1850 D. And then the last column is going to be your output. Okay? So what are my input values? Very good. Your input values are the days, right? 5, 6, 7, and 8. And now we want to evaluate for each one of those values of D. So the next thing we're going to do is we're going to substitute. Okay, now we're going to substitute. Here, D is equal to 5. So we're going to have 25 plus 1850 times 5. Here, D is 6. So 25 plus 1850 times 6. 25 plus 1850 times 7. And 25 plus 1850 times 8. And now all you have to do is do your simplifying. Substitute and simplify. Remember, that's what evaluate means? Substitute and simplify. So, go ahead and do it. What am I going to do first in this first expression?
times by 5.
Very good. So 1850 times 5 And then you add the 25. How many times am I going to add that 25? Just once. Just once. Let's, so we've got 117.50. Remember, in your calculator, it says 0.5. This is money, so we have 50 cents, right? And the last one, 1850 times 8 plus 25 is what? 173. Very good, 173. So, we wrote our equation, we created our table, and now we need to graph it. So now we graph. This is x, comma, y. Okay? X, comma, y. And now you're just going to put it on the graph. Now, down here is days, right? The number of days determines how much it's going to cost you, right? Does everybody see that? So the days is the independent variable. It's the one that causes the other one to change. So days go down here. That's D. And then over here, cost is the M. So now we can graph.
Why does it keep glitching?
So 5, comma, 117.50. So this is 110, that's 120. 117 is about 117.50, about right there. Approximately. Okay? 6, comma, 136. There's 30, there's 140. 135 is in the middle, so it's just a little bit above the middle. 136. Numbers 7, comma, 154.50. 7, comma, 154.50 is about right there. And 8, comma, 173. 8, comma, 173 is about right there. And there's your graph. What kind of graph is it?
Linear.
It is a linear graph. Very good. It's a straight line. Now let me ask you, okay? If you can't keep your dog in there for a half day, well, you can pick him up in the middle of the day, but they'll charge you a whole day. Can I graph 5.5 here?
Yeah.
No, because they're going to charge you for a full day anyways. Like, so you cannot. If you keep the dog in there for half a day, you're still going to get charged for the full day. It's like staying at a hotel, right? Even if you're going to check out halfway, they're still going to charge you for the full day, right? Or if you're buying an amusement park ticket, right? You still have to pay the whole cost of the ticket, even if you're going to only stay part of the day. Does that make sense? Okay? So, because you cannot have any partials of a day, okay, you do not draw your line. Does that make sense? Is everybody clear? All right.